Next section is the fill in the blank section. The few things you need to know for fill in the blank section. You need to know that, I'd be sure you put this on your cheat sheet, protons plus neutrons equals mass. Protons equals electrons unless, what am I going to say? Unless there is a charge. Now, of course, if there is a charge, a negative charge equals the gain of electrons, and a positive charge equals loss. And then if you need to know that atomic number equals protons, and you want to know that a number like that in that hyphen notation, that's mass. All right, so here we go. Atomic number 13 is aluminum. So we're going to put aluminum and put a 13 down here for its protons. It has a mass of 27, so we can put a 27 up there. Protons are the same as atomic number. Electrons equals proton unless there's a charge. There's no charge in this chart. Neutrons would be protons, so 13 plus something equals 27. So it looks like it'd be 14. And the hyphen notation is aluminum 27. Aluminum is the name and 27 is the mass. Down here you got 82 electrons, but since there's no charge, there are 82 protons. 82 protons means the atomic number is 82. The symbol's lead. It's going to be 82. We have to figure out what the mass is. So it'll be 82 and 125. So we're looking at lead. Whoops, L-E-A-D. Start that again. Lead 207. 207. Okay, if you add those two numbers, 82 and 125, you get 207. So that's your mass. Down here is potassium 39, so you have to look at the periodic table to find the atomic number of potassium. It's 19. 39 is the mass. The atomic number then is 19, as well as protons. So we already know the mass is 39. The electrons equal the protons if there's no charge. And the neutrons would be 39 minus 19 because the protons plus the neutrons equals the mass. And you know there's 19 protons, so 19 plus something has to equal 39. That's where I got the 20. Now at the bottom section, you've got these charges, so you got to deal with that. So if it's calcium, the nuclear symbol would have a 20 down there. The atomic number would be 20. Now we know that by looking at the periodic table when calcium is number 20. The mass, it tells us, is 41. The protons equals the atomic number. The electrons are equal to the protons unless there's a charge. So there would normally be 20 electrons, but there is a charge here of positive 2. If you remember up the top, we said that positive charge equals loss. So if you've got a positive 2 charge, it means you've lost 2 of them. And I had to put an 18 in here. And that's plus 2. All right, the neutrons, protons plus neutrons equals mass. Since the mass is 41, 41 minus 20 is 21. Down here you got 18 electrons, but that includes 2 electrons that have been gained. So the normal number of electrons would not be 18. Instead, it would be what? 18 includes the 2 that were gained. So normal would be 16. So that'd be your 16 protons, which is the atomic number. The mass number is the protons plus the neutrons, so you got 16 and 16, so it'll be 32. And the element with 16 electrons is sulfur, so we'd put a 16, we'd put a 32 here for its mass, and we'd put a negative 2 charge. This one says atomic number 17. So 17 is chlorine if you look at your periodic table. So you put a 17 here, and it tells us the mass is 36, so we'll go ahead and put that in. Protons equal 17, because that's the same as the atomic number. The neutrons would be 17 plus something equals 36, so it'd have to be 19. And since we have one more electron than we do protons, there's a negative 1 charge. And down here we got a similar situation that we had in line 2. We got 18 and a negative 2, so 16 would be our normal protons. And the atomic number, of course, it also matches that. The mass number is protons plus neutrons, so here we got 16 plus 18. And the element with 16 protons, again, is sulfur, 16, but this time the mass is different. It's not 32, it's 34. So these two guys right here are called isotopes, and they're because they've got different numbers of neutrons. So they're isotopes because different numbers of neutrons. They are also ions because they both have a charge. And that is the end of the chart section.